We've learned a number of rules, so I went ahead and put them at the top here just to remind you. We have power rule, exponential rule, product rule, quotient rule. These should all be things that you've practiced in other problem sets already. And by the way, the conjugate is over here just in case we're going to need it. But we've just learned in the last lesson, and if you're just doing the problem set playlist, you skipped it. But if you've also skipped calculus or pre-calculus and everything else, you can still just walk with me here on this one. As long as you embrace that the derivative of sine is cosine, and the derivative of cosine is negative sine. And that means, of course, the derivative of negative sine would give me negative cosine, and derivative of negative cosine would give me positive sine. So you can just keep going in circles like that forever. It's wild. And I want to focus on one problem here, which is this one. I think it's the hardest one in this particular problem set, so I want to do this one first. And it's a function. It's a function of theta, so I'm going to call it f of theta. And that's equal to secant theta, which is a stupid term, tangent theta. And I'm going to rewrite that as what it really is 1 over cosine of theta times sine of theta over cosine of theta. Why? Why do I do this? Because I want to remember that this function is a product rule. These are multiplied items, but inside each of them will be a quotient rule. This needs a quotient rule to come work into the equation. If I want to find the differentiate, or what am I calling it? The derivative of this function, well, I see that it's a product rule. This is two things that are multiplied. So I know it's going to be u prime v plus v prime u. That came right out of the product rule over in this column here. And we know what u is. We know u is 1 over cosine of theta. And we know what v is. V is sine theta over cosine of theta. But here's where it gets tricky. I have to find u prime to do this. And to do that, I'm going to have to quotient rule this. So let's come down here separate. Maybe I'll write it in just a different color, slightly different color. What kind of color can I give it? Let's give it like something a little bit lighter maybe. Is this enough? That should be just enough. Let's maybe change it just a little more. I want this to be kind of obvious. Let's change it a little bit more. I like this color. Okay, so to find u prime for this, we're going to name a new u and v. And now you see why I'm using the different color. The numerator for this is 1, which means the derivative of it is 0. And the denominator is cosine. These aren't the same, right? One of them is in the larger function. We're using this subfunction here to make our u's and v's for our quotient rule. Do not get that mixed up. My v prime is negative sine of theta. So let's make the quotient rule up so that we can find our actual u prime here. And that's u prime v, which is 0 times something, because it's still 0, so that's out, minus v prime, which is negative sine theta, times 1. So we just get positive sine over v squared, which is cosine theta squared. Okay, so this is our u prime here. Now let's do the same thing to find v prime over here. Should have just copied it like that. Okay, so what's our u, our numerator here? That's sine. And our u prime is then, it's going to be cosine. Our v for this is cosine. And our v prime is, can you guess it? Negative sine. Okay, so let's do the quotient rule. U prime v cosine theta times cosine theta minus v prime, so it becomes plus sine theta times u, which is sine theta, all over v squared. so cosine theta squared. And cosine squared plus sine squared, what's that give me? That's 1. That is an identity that's equal to 1. So we have our u's, and we have our v's and u primes and v primes. Now let's look at the original function, and remember the product rule is what we're working with for this actual function up here. Those quotient rules were just to solve for the derivatives of each one of these constituents so that we can apply these 4 into the actual product rule here. So let's come back to my real ink color, my favorite blue. What's this doing here? What are you doing down here? Let's fill that in. It's just going to bug me. Okay. So u prime v is sine of theta over cosine theta squared. You might write cosine squared theta like this, but that's stupid. That is stupid. It's just confusing to everybody and unnecessary. Write it on the outside and tell your teacher to call me if they have a problem with it. This is u prime v. What's our v? Our v is up here. It's a tangent, right? So that's a sine over a cosine. Plus v prime, which we found over here is 1 over cosine theta squared, times u, which is 1 over cosine theta. And it looks like we have a common denominator, so I'm going to write it as this. And this is the answer. Now, you may be asked to do stupid things with this. You may be asked to separate this into a different fashion, like sine of theta squared over cosine of theta squared times 1 over cosine of theta plus that second part, which is plus 1 over cosine of theta cubed. And this becomes tangent of theta squared. And 1 over cosine is secant theta. And conversely over here, you can do the same thing. You can say like secant. You could even make this secant theta cubed. You know, there's a million ways to write this out. You could separate that into secant theta, and then you could say tangent theta squared plus secant squared. You can do all kinds of stuff, and it's all stupid. You can't even read that. You don't know what that means. But when I look at this here, I know what sine and cosine are. And this is what we do derivatives with. This is what we do work with. Do it in sine and cosine. If your teacher asks for this kind of stuff, it's because they don't actually know math. And they're trying to cover it up because they're bald and their mustache is too long or something like that. I don't know. I don't know. And by the way, being bald is okay as long as you maintain your scalp, right? It's all about hygiene, guys. But in the case of math, keep it into sine and cosine. And this explanation is so hard for just a simple secant tangent. But now you understand that you will break things into a quotient rule and product rule, and you'll do subset of a subset of a subset, and now we can cross this one off because we found the answer for it, which is correct. And I'll see you for the others in the next video.